Welcome, grade 9 students. HALINA'T MATH-TUTO. We are now in fourth quarter period, and in week 1, we will discuss about the 6 trigonometric ratios. But before that, let's have first the lesson's objectives. At the end of the lesson, the students are expected to, number 1, illustrates the 6 trigonometric ratios. Number 2, identify the 6 trigonometric ratios in a right triangle. And number 3, determine the ratio to be used in solving the unknown parts of the right triangle. These objectives are based on the most essential learning competency prescribed by the Department of Education in week 1 of quarter 4, which is illustrates the 6 trigonometric ratios, which are sine, cosine, tangent, secant, cosecant, and cotangent with the code of M9GE-IVA-1. Let's now start discussing trigonometry. So the word trigonometry comes from the ancient Greek word trigon, meaning triangle, and metron, which means measure. So when we are talking about trigonometry, it is a branch of mathematics that deals with triangles measurement. The Pythagorean Theorem that has been discussed to us from quarter 3 is used to solve for the right triangle. However, its use is limited only to solve for the unknown sides of a triangle. But how can we solve if one side and the measure of an angle is given? Solutions for this kind of problem makes use of trigonometric ratios. So trigonometric ratios are defined by means of the acute of the right triangle. Let's now start discussing the 6 trigonometric ratios. We have the sine, abbreviate with SIN, cosine, COS, tangent, TAN, cosecant, CSC, secant, SEC, and cotangent abbreviate with COT. Ang sine, cosine, and tangent ay makikita natin sa ating mga scientific calculators. Cosecant, secant, and cotangent are known as the reciprocal of sine, cosine, and tangent respectively. Let's discuss the right angle triangle. We all know that a right triangle is a triangle whose one angle measures 90 degrees. Based on our given figure, we have here the Greek symbol theta, which denotes as our angle. We will also use the convention that angles are symbolized by capital letters, while the side opposite each angle will carry the same letter symbol in lowercase or small letter. Let's discuss the sides of the right triangle, which are the adjacent side, opposite side, and the hypotenuse. Adjacent is adjacent or next to the angle. So, pag sinabi nating adjacent side, katabi. Kung ito ang ating given angle, ang adjacent side sa kanya ay si small letter A. Opposite is opposite the given angle. So, if this will be our given angle, ang side opposite ay si small letter B or si side B. The longest side is the hypotenuse. Always remember that the hypotenuse is the side opposite of the 90-degree angle. Let's discuss SOHCAHTOA. So, SOHCAHTOA is a mnemonic used in remembering the equation. So, we have here triangle ACB. Given our angle or theta, the side opposite is side B, the side adjacent is side A, and the hypotenuse is side C. Okay? So, let's start with So, SOH. So, we have sine theta is equal to opposite side over the hypotenuse. So, kung titignan natin sa ating figure, ang opposite side kay given angle ay si B and the hypotenuse ay si side C. So, opposite over hypotenuse, we have B over C. Cosine theta is equal to adjacent side over the hypotenuse. So, the adjacent side is A and the hypotenuse is C. So, we have here A over C. And we have TOA. So, TOA stands for tangent theta is equal to opposite side over the adjacent side. So, opposite side is side B over the adjacent side, which is side A. So, we have here B over A. We also have the reciprocal of SOHCAHTOA, which is CHO-SHAKAW. Okay? The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So, again, let's have our given figure. So, we have here CHO. So, it stands for cosecant theta is equal to hypotenuse over opposite side. So, the given hypotenuse is C and given opposite side is B. So, we have here C over B. SHA. So, SHA stands for secant theta is equal to hypotenuse over the adjacent side. So, the given hypotenuse again is C and adjacent side is side A. So, we have here C over A. And COW stands for cotangent theta is equal to adjacent side over opposite side. So, given our adjacent side is side A over the opposite side, which is side B. So, cotangent theta is equal to A over B. Let's have the first example. So, find the six trigonometric ratios. So, given triangle ACB, wherein side A is 3, side B is 4, and side C is 5. So, we need to find out sine A, cosine A, tangent A, cosecant A, secant A, and cotangent A. So, ang focus natin ay si angle A. So, what is the measure of side opposite ng angle A? Okay, that is 3. Okay? Side adjacent kay angle A is 4 and the hypotenuse is 5. So, sine A, which is opposite side over hypotenuse. So, opposite is 3 and then hypotenuse is 5. So, we have here sine A is equal to 3 over 5. Cosine A is adjacent side over hypotenuse. So, adjacent is 4 and hypotenuse is 5. So, cosine A is equal to 4 over 5. Tangent A, which is opposite side over adjacent side. So, ang opposite is 3 and ang adjacent side is 4. So, we have here 3 over 4. Cosecant A is the reciprocal of sine A. So, cosecant A is hypotenuse over opposite side. So, we have here, so i-reciprocal lang natin yung 3 over 5. So, we have here 5 over 3. Secant A is hypotenuse over adjacent side. So, we have here 5 over 4. And cotangent A, that is adjacent side over opposite side, which is 4 over 3. Let's have another example. Okay. So, side B is 7, Side C is 25. And side A is unknown. So, dahil nawawala yung isang side ng right triangle, we have to use the Pythagorean Theorem. So, we have here C squared is equal to A squared plus B squared. So, ang measure ng ating side C is 25 and ang measure ng ating side B is 7. So, we have here C squared, that is 25 squared, is equal to A squared, yung ating nawawalang side. So, remain lang siya doon, plus ang ating B squared, which is 7 squared. So, evaluate natin, 25 squared, that is 625, is equal to A squared plus 7 squared, that is 49. Combining like terms, so we have here A squared is equal to 625 minus 49. So, A squared is equal to 576. Get the square root of both sides. So, we have A is equal to 24. Okay? So, we need to find the 6 trigonometric ratios of angle. Okay, B. So, we have your sine B. We need to find sine B, cosine B, tangent B, cosecant B, secant B, and cotangent B. Okay, so analyze natin yung mga measures ng sides ng ating right triangle. So, ito yung ating angle B. Side opposite is 7. Side adjacent is ang A natin, which is 24. And the hypotenuse is 25. So, sine B, that is opposite over hypotenuse. So, we have here 7 over 25. Cosine B, that is adjacent side over hypotenuse. So, adjacent is 24 and ang hypotenuse is 25. So, we have here 24 over 25. Tangent B, that is opposite side over adjacent side. So, we have 7 over 24. And then, we have cosecant B. So, get the reciprocal of sine B. So, meron tayong 25 over 7. Secant B, reciprocal ng cosine B. So, we have 25 over 24. Secant B is hypotenuse over adjacent. Okay? And cotangent B, that is adjacent side over opposite side. That is 24 over 7. Let's move on in showing a formula for the missing parts of a right triangle. So, given is triangle BAC, wherein angle B is 65 degrees and side A measures 17. So, we need to solve for side B, side C, and angle C. Okay? So, let's analyze our given triangle. So, side B is the opposite side of our given angle na 65 degrees o yung ating angle B. Side C is the adjacent side of angle B. Okay? So, if we solve for side C, we need to use ka. Or cosine theta is equal to adjacent side over the hypotenuse. Okay? So, cosine B is equal to ang ating adjacent side na C over the hypotenuse natin na A. And then, substitute lang natin yung values. Okay? So, cosine 65 degrees is equal to C over ang A na 17. To solve for side C, we need to cross multiply. So, C is equal to 17 cosine 65 degrees or 17 times cosine 65 degrees. Okay? Masosolve na natin kung ano man ang measure ng side C. Okay? Next, solve for side B. So, dahil si side B ay opposite side ng angle B at given din sa atin ang ating hypotenuse na 17, so, to solve for side B, we need to use SO. Okay, so sine theta is equal to opposite side over the hypotenuse. So, we have your sine B is equal to ang opposite side na B and the hypotenuse na A. So, we have your sine B is equal to B over A. So, substitute ulit natin. So, we have your sine 65 degrees is equal to b over 17. So, to find out what is side b, so cross-multiply lang natin. So, we have here b is equal to 17 sine 65 degrees or b is equal to 17 multiplied by sine 65 degrees. Okay? Now, to find angle C, dahil si angle B at si angle C dito ay complementary angles, then para makuha si angle C, subtract natin yung 90 degrees kay 65 degrees para makuha natin ang measure ng angle C. Okay, so what is more? So, try to answer this given. So, we have your triangle MAN. So, we need to find sine M, cosine M, and tangent M. Given that side N is 5, side M is 12, and side A is 13. Okay? Okay. So, where do we apply trigonometry? So, cite a situation by illustrations and explain how to determine what trigonometric ratio to use when solving for the unknown parts of the right triangle. Um, in solving for the unknown parts of the right triangle, we will discuss that further in our next lesson. Okay, so let's wrap up our discussion. So we discussed about the six trigonometric ratios and the mnemonic. Okay, for easily remembering the equation, so we have here the SOHCAHTOA, which is sine theta is equal to opposite side over the hypotenuse. Ka stands for cosine theta is equal to adjacent side over the hypotenuse. And TOA is equal to tangent theta is equal to opposite side over the adjacent side. We also discussed the reciprocal of SOHCAHTOA, which is CHO. Okay, so CHO stands for cosecant theta is equal to hypotenuse over opposite side. SHA stands for secant theta is equal to hypotenuse over adjacent side. And COW stands for cotangent theta is equal to adjacent side over opposite side. And we also discussed on how to find the missing sides and angles of a right triangle by using the trigonometric ratios. Okay? So that is the end of our discussion. So if we have questions, feel free to message your math teacher. So thank you for listening.